Good afternoon, everybody. Thank you for joining today's webinar. My name is Augustus Melu, a business relationship manager here at Unicom Seminars. We are delighted to be hosting today's webinar titled HashiCorp Tooling, Value, Efficiency, Security, presented by Jordan Taylor, DevOps practitioner with Continue. There will be opportunities for questions and answers at the end of Jordan's presentation. We hope you enjoy the webinar and welcome your feedback. At this point, I would like to hand over to Jordan.
Hey guys, welcome to the Continue HashiCorp Tooling webinar. So today we're going to speak about how the HashiCorp tools can add value, efficiency and security to your organization. So I'm Jordan Taylor. I'm a DevOps practitioner at Continue. I specialize in automation, configuration management, cloud orchestration and CI/CD. And currently my favorite tools are Terraform, Docker and Vault, two of which we're going to speak about today. So for a start, you will avoid initial investment. So you don't have to get the physical infrastructure that you require in order to get all of the resources that you need. And in the process of that, you have a lot of cost savings there as well. It also provides you the flexibility, so you can add nodes as you need, and you can also take them away as you need. You won't have that wasted infrastructure when you don't need it anymore. You also have the scalability to just scale up when the need is there. So when you hit a particular level of traffic, you can easily spin up another web server in the cloud rather than having to wait a large amount of time to get that new resource. It also gives user control to your teams. So your project teams or your development teams could build up their own test environments in the cloud with ease. They don't have to go through a series of processes in order to actually get all of that infrastructure in place. And also the speed of deployment. So as I mentioned before, you don't have weeks of waiting time or months even to get a new virtual machine or some new physical infrastructure. It can be up in seconds. So with Terraform, you could have a new virtual machine within seconds. And also in the cloud, you get out of the box security and monitoring. So take AWS for example. You have CloudWatch, which gives you a lot of information on all of the resources that you have in the cloud, as well as the security that you get with that. So the VPCs that you will have your resources set in, and also the security groups that you can have associated with your machines to make sure that the networking is as secure as it can be. So how can you do that? Magic code. So the use of cloud orchestration command with Terraform, for example. So you could have new resources in the cloud in just one line command. And also it provides the opportunity to auto scale. So when your resources hit a certain level, receive a certain level of traffic, you can also make it so your infrastructure will scale up as is required, and then it can automatically scale down as well when the traffic goes back to a lower state. But you can't do that if you're not in the cloud as easily, because you will have to have those reserved infrastructure ready to go. And also, in the process of that, you also have much less complicated deployment processes. So the workflow that you have with Terraform would mean that you can do it all yourself, and infrastructure as code, and one command will build into the cloud. Whereas you don't have to go through a series of hoops to actually get new infrastructure to be deployed into your environments. And at the top of all this is automation. So automation is making all of this efficient for you, and that is going to add value. So this brings us into HashiCorp. So HashiCorp are in San Francisco, and they looked at challenges in development, operations and security. So that means they try and tackle manual processes, get rid of that to become more efficient, complex workflows to become more efficient, insecure systems, so make things a lot more secure, and also make it so you don't have constrained resources anymore. And above that, you're allowing business critical tasks. So you can, if you look to adopt the HashiCorp tools, because they're already looking to solve all of the challenges that your organization has, that your organization has, it means that you can focus on the business critical tasks and let all of your new workflows and your new tools that will take care of all of this automatically with the efficiency and security that the HashiCorp tools provide, and make sure that you can add value, the maximum amount of value that you can achieve. So let's have a look at some of the tools that HashiCorp offer. So just briefly, so you have Vagrant, which is your lightweight, reproducible, portable development environments that you can use, and it is infrastructure as code also. You have Nomad, which it allows you to manage and schedule clusters to provide a workflow of deploying applications across your infrastructure. Packer, so that will allow you to create images for an array of different cloud platforms, all from a single source configuration. We also have Vault, so secure, it allows you to secure, store, and control the access around any of the secrets that your organization might have. So then we also have Terraform, so you can create, combine, and manage infrastructure across multiple cloud providers, all from one place. You then have Console, which is a multi-data center aware tool for service discovery, configuration, and also orchestration with Console as well. And then you have Surf, which is a lightweight, decentralized solution for cluster membership, failure detection, and also orchestration. And then we have Otto. So Otto is a tool that provides a single consistent workflow to develop and deploy any application on any cloud provider, and it utilizes most of these tools. So here, look at Packer for image creation, Vault for the security key management system that it offers, and also Terraform, which will allow you to build into the cloud and manage your cloud infrastructure. So the agenda. So first off, we'll have a look at Packer. We'll have a look at some of the technical functionality, why you should look to adopt Packer, and maybe some best practices as well. The same for Terraform, and then we'll have a look at how Contino have taken Packer and Terraform into a UK retailer, and what the value we've added there, and how simple it has been to move that UK retailer into the cloud. And then we'll take a look at Vault as well to see how it's working and how it could add value to your organization. So Packer. So Packer allows you to create images from an array of platforms or from a single source configuration. Why should you adopt Packer? So all of the images that you want to deploy into your cloud, you can have them templated as code. And because they're templated as code, it means you can store them in source control as well. And now that you have these templated images, it allows you to pre-bake and pre-configure images ready to go. So you could have 50 images, all 50 of them configured differently to perform different roles in your infrastructure, and they could be ready to use within seconds because you've already templated and configured all of these images ready to go. Packer also provides the capability for developers as well. So developers can template their own images, which would form their own development environments, which could have software development kits that particular developers need. But Packer allows for that capability there. And there's also little upskilling required to take on Packer because the domain-specific language, or most of the HashiCorp tools, is very easy to pick up. And for Packer, it's JSON, so it's very easy to work with. So the Packer technical functionality. So is an abstraction of the cloud provider API. So what it's doing in the background is it's looking at the templates that you write out, and then it will make calls to the particular cloud provider you're aiming it at, and it will build your resources and create your images there. So it will is working is it will build a temporary cloud instance via the API, and then it will provision it and configure it according to how you specified in your template, and then Packer will snapshot it and save it within that cloud provider. So a Packer template. So this is what a Packer template looks like. So as you can see at the top there, we have the builders section. So this is actually specifying what you're about to build into the cloud provider, ready to be snapshotted. Excuse me. So we have the type at the top there. So we're saying we're going to build Amazon Elastic Block Storage, and then we're going to place this image in EU West 1. This is for AWS, by the way. And then the source AMI, so this is where you would specify your base AMI that you want to build on top of. So it could be Red Hat, it could be a Windows image. That's where you would specify that. Then the instance type, in this example, so the T2 micro, we're specifying how big this particular image will be, so how big the temporary node will be that gets snapshotted. And then you have the SSH username, so this is what Packer will use to SSH onto that node and do any configuration remotely that you specify within the template. And then we have here, so the AMI name, so this is what your Packer image will be named once you have snapshotted it. So in this case it says node, and then we have a timestamp. So what this will say, it will say node, and then it will say the date, and then it will say the minutes, hours, and seconds that it was built on. And then we have a pseudo terminal, an SSH pseudo terminal, and then we have provisioners here. So in this case, so that is the builders section created, written out. And what that will do, that will form your temporary image ready to be snapshotted. And then the provisioners section will do all the extra configuration that you want to do and have ready and snapshotted. So in this case, we're calling the Chef Solo provisioner. So we're running Chef within this temporary node without any access to a Chef server, using a cookbook that we specify. So Packer will take that cookbook, place it onto the node, run Chef within the temporary node, and then once Chef has finished the provisioning, it will then snapshot it. So that is an example of a Packer template. So some best practices around Packer. So with Packer, and it keeps things very tidy, especially when you're writing infrastructure as code. So you can see here that we have an AWS directory. So this means any Packer templates that we're going to build that are going to be in AWS should be in here. And then below that level, you should then have the operating system of these particular Packer templates. And then below the operating system, you should then have whatever particular role each of these templates will form. So we have a console template. We have a console image that will be built. It will be a Ubuntu image, and it will be placed in AWS. But this just keeps things tidy and it keeps things organized. So any other developer that picks them up and wants to use them can do so. We then also have the config and the scripts. So anything that each of these templates will be using in terms of the extra configuration and provisioning that will take place, they are also stored in the same repository, but in such a way that they're easy to access and they're easy to understand what is actually in there. So config you have related to each of the roles that are being used here, and then scripts you would obviously have to split them dependent on whatever operating system that you are going to be using them with. And then also it's very important to name your images correctly, especially if you're templating out your full infrastructure, all pre-provisioned, ready to be picked up by Terraform. It's important so that you can easily understand what's going on, and timestamping it means that you can version control all of your images as well. So naming them correctly and also making sure that you timestamp them is key. So now we move on to Terraform. So Terraform allows the creation, combination, and management of infrastructure resources across multiple providers. Why should you adopt Terraform? So Terraform, similar to Packer, is infrastructure as code, which means your whole cloud infrastructure can be templated in source code, and then it can all be stored in Git, and it can be ran from anywhere. It doesn't have to go through a series of processes. You don't have to do it through a UI to make things happen. It is code, and code is easily transferable and easily understood. It also allows you to provide on-demand infrastructural flexibility. So no longer, as I keep on mentioning, no longer do you have all of these processes to get these new virtual machines or these new resources in the cloud. You can do it in one command. So with Terraform, you would just write out the template of the resource you want to build into the cloud, which cloud you want to build it in, and that's it. It can be there within seconds. And similar to Packer as well, the DSL for any of the HashiCorp tools that you will use is very easy to pick up. And all of this makes it so it makes it so easy for you to move your teams or your projects or your full organization into the cloud should you wish to, because documentation around these tools is very, very easy to understand, and it's well written, and the tools are very well designed. So it is definitely a simple step towards the cloud. So Terraform technical functionality. So of the cloud provider's API, templated as code. So it will interpret the templates that you have, and it will then make the correct API calls to the cloud provider to build the resources that you have specified with the configuration that you have specified as well. And then it will do any provisioning that you've stated as part of the templates that you've written out. And then once you've deployed into the cloud, it'll then store it in something called the state. So the state is how Terraform tracks every single bit of infrastructure that it has built into a particular cloud provider. So then in future, not only have you just built your resources, but you can also manage them with Terraform. So because Terraform tracks all of the metadata of everything it builds, it can make it so it is easily to just access those via the API and manipulate them via the API, but you don't deal with any of that because you have written the code. Everything you do is templated, and then Terraform takes care of everything and interprets the code that you've written out as a template. So you would write the template, so all of the resources you want, whether they're instances, whether they're security groups, whether they're VPCs, any networking you can think of, and then you would execute a Terraform plan. And what Terraform plan does is it shows you what is about to be built in the cloud provider. And then once you're happy with what is about to be built, then you can say Terraform apply. And what Terraform apply will do is it will build everything that you have stated in your templates into the cloud provider. And once that's successful, it will store all of the metadata of all of the resources that you've deployed into the cloud. And then there you have it. Your infrastructure is in the cloud, ready to be managed by Terraform. So let's have a look at a Terraform template. So at the top here you can see each of the variables that are going to be used within. So these are just declared so that they can be used within this particular class. In this class we're actually pulling the majority of all of the values from a different variable file. But you can see you can specify some defaults up here as well. And then you have the resource, which is the important part. So here we're saying a resource, an AWS instance, which is going to be a virtual machine in AWS, and then the name for this will be training instance, and then we're saying, right, we want you to use this particular AMI. So this could be an AMI that you've just pre-provisioned with Packer, all configured. You could specify the AMI ID here, and this instance would use that. You then specify the instance type. So that again is how large this particular instance will be in the cloud provider. You then have a count, so the number of this resource that you want in the cloud. Then your security group, so the ports that need to be opened or closed for this particular node. And then the key name. So in AWS, for example, you would have a selection of SSH keys that you would assign to any resource that you build, any instance that you build. And that is how you would be able to SSH into these particular resources. So and then here we say the connection. So any provisioning that you want to do as part of Terraform, Terraform will have to be able to SSH into that box in order to perform the remote commands. So here this is saying the user, so the Ubuntu user, because we're building a Ubuntu instance, and then whatever key you've specified here, you would also have it locally here. So you point Terraform to a connection key file path, which is the absolute path to your local key that you have from AWS. And then here we're specifying some tags. So This is what the instance would be named within AWS. So training 0 if you only had 1, or if you had 3, you'd build training 0, training 1, and training 2. And then we move on to the provisioner. So provision is this particular provisioner that we're using. So a remote exec, which means Terraform will be SSHing into the box, and it will run a command remotely. So in this case, we're just activating the password authentication when you log into the particular node via SSH. We're restarting SSH, and then we're adding learner to the sudos group. But this is a Terraform template, and as you can see, it's just a set of data that you would do through the GUI if you wanted to do it through the actual cloud provider itself. But this is templated as code, which you can store in GitHub, and once Terraform has created this, you can then manage it with Terraform. So some best practices around Terraform. So it's very important to store state wisely, because anything you build, so any Terraform classes that you have within a directory, when you say Terraform apply within that directory, it will build all of the resources that you have specified within each of the classes within that directory. And once you say Terraform apply and you've built all of your resources, it's then going to create a Terraform state file for all of the resources from that directory, which means that every directory of classes will have its own Terraform state. And that means you could manage multiple environments from a single repository if you get your directory structure correct. But storing and sharing the state is something that should definitely be thought about, because where you store it, so if you're collaborating with teams, each of your developers that are going to be building resources with Terraform all need the same up-to-date Terraform state file. And the only way you can do that, so you could put that into GitHub, you could make sure you could communicate well, you could make sure that each of your team members do pull that down, or you could just make it so Terraform only runs from one place. So you push your code and you could run it from a single place. So that could be Atlas, which is HashiCorp's well thought out implementation of allowing this collaborative development, or you could use something like Jenkins, a build platform, or you could even just make sure that you only run Terraform from a single developer's laptop. But thinking about where you store this state and how you share it is critical with Terraform, because if you make particular changes to the code and you do a Terraform plan, you will probably see that it's going to destroy and recreate some of those resources that you have in the cloud. And if that's a critical resource, then you don't want that to happen. There needs to be communication, there needs to be workflows around these things. Structure a little bit more. So as I said, all of the classes that are in particular directories for Terraform will be picked up when you say Terraform apply within that particular directory, and then a Terraform state will be created in each of these directories. So here is an example of a best practice way of setting up a Terraform repository. So at the highest level, you would have your cloud providers, so AWS, Azure, GC, Rackspace, and then within each cloud provider, you would then say your environments. So we have dev, pre-prod, prod, and test. So in each of these, we would have a series of Terraform classes, and running Terraform apply in one of these directories would mean it will build all the resources that were associated with this particular environment. But you won't actually declare any resources in here. You would just declare modules with parameters that you want to use to customize modules. So down here we have the modules. So this is where you would actually declare each of your resources, but you would also write them in such a way that they can be reused and molded dependent on what your environment requires. So you could have a Jenkins node in here, you could have a web server we could have a web server in here, a load balancer, but you would write it in such a way that it can be reused. And then all you do in your environment is you would just call upon that module, pass it the parameters that are specific to that particular environment, and there you have it. You have code reuse. But directory structure is key with Terraform. So, as I said, you do need a strong workflow around using Terraform. You need strong workflows around everything, and there is a solution to that. So instead of instead of trying to think about how you should be storing your state and how you should be sharing it, HashiCorp have already thought about that. Terraform Enterprise will use something called Atlas. So what Atlas provides, it allows you to do remote Terraform plans, applies, and it also allows lock. So you can run Terraform from one central place, Atlas, and this prevents any conflicting changes or potential downtime which could happen because multiple people are changing the code, multiple people are trying to build the code. You can stay away from that. Also, it allows for change management and access control. So every change generates a plan, every change to your code. And this can be configured in such a way that there are only particular users that have the ability to actually apply that code. So you could have your developers say, right, we think this code will work, this is what we want to add to the cloud, and then you need an approved operator that can see the plan within Atlas and say, right, that can go ahead and that can be built into the cloud. That's as safe as you can get. And then there's also a GitHub integration. So you can collaborate through GitHub, and then everything you push into GitHub is automatically validated to make sure that it would build the resources that you specify. And then, so we also have the remote state storage as well. So, you can prevent conflicts by storing state in one place. So you could store it in S3, you could store it in console, you could store it in Atlas, Artifactory. There are lots of different places you can store it. And then you also have the artifact registry. So you can build and store machine images. So machine images with Packer, you can store them in Atlas, ready to be used by Terraform. And then you've also got your notification integration as well. So everything you do with Terraform can send out emails. It can inform you via Slack or HipChat or whatever you want to use with it. And Terraform Enterprise also allows auditing capability. So every state that gets applied by Terraform, you will have a state history in Atlas, which means you can see the differences between states and what has actually been built in the past. And that also means that you can roll back to previous states of Atlas. So if a faulty change goes out, you can immediately roll back to a healthy state of your infrastructure. So now let's take a look at how Contino took a leading UK retailer into the cloud. So the client's required to equip the workforce with the ability to move into the cloud. And with that, they wanted a templated cloud architecture that they could just give to a new team that had been selected to move into the cloud, and they could use that. They could reuse what other teams had used with this Terraform and Packer and just modify it to what they need, and then they could be in the cloud within a week. And with this, it gets rid of the inflexibility of having physical infrastructure that was long-lived or would be hard to expand, which also means that you're scrapping all of the complex deployment processes. But because we took these tools into this retailer, it meant that all of these things were not unachievable. It made them simple. So what did we deliver? So we delivered a templated AWS architecture as specified, which included multiple VPCs with multiple different nodes, all of the networking configuration that a project would need, all ready to go. So all of the examples were there. So any team that did pick it up in the future could have done that with ease. As part of that, we also integrated with teams throughout the development to ensure that everybody was being trained at the same time as we were developing. So essentials training was carried out to large audiences to make all the developers excited to be taking on these new tools. And then as part of that, the select few key engineers that were going to be taking on this code and owning this code were trained to a level that they could go and they could perform the exact same training that we had just done for them. And as part of all this, it meant that a project team had been moved into the cloud. So they were now fully in the cloud, and they were not dependent on us anymore, because they had the full skill set to not only operate the code that they had been given ownership of, but they also had the ability to teach the rest of the organization how to take on these tools. And that is how Contino works. So what were the outcomes of that for this UK leading retailer? So the teams were orchestrating infrastructure into the cloud with Terraform. And the workflow they selected around Terraform was that they ran it from Jenkins. So everything was ran from one place and they avoided conflicts that way. And then they also created pre-provisioned images with Packer, which were then also used by Terraform. So things were pre-baked, ready to go, and ready to be built by Terraform. It also meant that developers could pick up these images, and they had a series of pre-provisioned SDKs ready for them to actually do the development, rather than waiting for development environments to be spun up. They were also demonstrating configuration management capability. So their configuration management tool, their selected configuration management tool was Chef. So and all of the configuration management tools slot in with Terraform as well as Packer. So in this case it was Chef, and the teams were using Chef without any previous skill in it. Once we had given them the knowledge of how to use it, and after their training, they were fully provisioning their own infrastructure into the cloud. And all of the code that they worked with was stored in Github, which was also a new addition to their workflow. And once they'd taken on all of this information, they were ready to further upskill the organization without any dependency on Contino. So if you wanted to do that yourself, then we do offer a cloud enablement package as well. So you could do a 2-day course in AWS Essentials, which would make it so everything you need to know about AWS in order to get your organization into the cloud will be dealt with there. And all the Chef Essentials, so all the configuration management that you need to do, with the Chef Essentials, we would teach you everything you need to know to get started with that. And then the Packer and Terraform training, so the Essentials and the Intermediate, will teach you everything you need to know in terms of pre-baking and configuring Packer images, how everything works, the workflows that should be surrounding the Terraform operations that you want to carry out, and you will be ready to deploy a project into the cloud by the end of that cloud enablement package. So now let's have a look at Vault. So Vault is a secret management system by HashiCorp, and it's designed to be an automated way of dealing with any of the secrets that have to flow amongst your infrastructure. So secure infrastructure automation. And the way it does that, so it has secure storage, which is all of the encryption that's gone around Vault, and then you have the dynamic secrets, which means that so you have secrets, any of the secrets that you have stored, then they can be leased and they can be revoked if need be, so they're no longer valid or usable. And you can also have leases on them, so they have a time to live, or they can only be used a certain amount of time. And also, past all of this, you also have a lot of auditing capability with Vault as well. So every bit of interaction that happens with Vault is auditable because it is all logged. So what is the value of Vault? So you have lots of secrets in lots of different places. For example, decentralized keys. So you could have SSH keys everywhere. You don't know who has these keys, and they're out of control. And that is where the limit of visibility is. So you don't know who has access to these secrets. You don't know what secrets there are, and there's also a poorly defined break glass procedure around that. So when everything does go wrong, and the secrets are out, what do you do? How can you make sure that there is damage control in place if you don't have that central control point? So what it provides a single secret source. So all of your secrets are stored in one place. But you might think that that's a single source of failure, but it's a single source of control, because if Vault is set up correctly, then it's impenetrable. If the workflow around it, the same with everything else, is correct, then there is no reason that it cannot be the perfect solution to handle all of your secrets. And Vault is designed in such a way that it is highly available. So a Vault cluster would all be talking to each other. If one Vault goes down, your secrets are safe because it is clustered and it's highly available. It's also designed around pragmatic access. So anything that humans can do with Vault, so can machines just as easily. And there's also the operational access, so the manual capability to interact with Vault, all done via the API, is very easy to understand and do. And it's just practical security as well. So no longer do you need hardware to make sure that all of your secrets are safe, because Vault can be deployed anywhere. So what are the components with Vault? So is you have one storage backend per Vault cluster, and it is where all of your encrypted Vault configuration is stored. And then where all your secrets are stored is the secret backend. So that could be a Postgres, it could be a MySQL, but all of your secrets are stored in these encrypted databases, and they're also where all the dynamic secrets are kept. So Vault can write these dynamic secrets, which can be revoked and changed and have leases attached to them, or like use counts and things like that. That is where all of the magic happens, in the secret backend. And then you have the audit backend, which is Vault, where all of the interactions that happen with Vault will go into the audit backend. So it could be a file, it could be into console. But if you have the audit backend enabled, and if Vault receives an API request and it can't log to the audit backend, that means that Vault will refuse access to that secret, because you have the audit backend active and it cannot log to the audit backend, then it will not give access to that secret, because it needs to have evidence of that particular interaction. And also you have the auth backend, so that is how Vault authenticates users to access Vault. So interacting with Vault, so Vault has a HTTP API which manages all the interactions. So all of the requests that you make to Vault go via that. And that's over TLS, which means so it's SSL, so secure sockets layer, and it's 256-bit advanced encrypt standard. So, and also then you have Vault works with tokens. So once you've authenticated, you get given a token, and that means that you now have access to a particular secret dependent on the policy attached with your token. And then Vault also has a barrier around it. So all data transitions that happen with Vault, in and out, are all encrypted, and that means Vault makes sure that all data is encrypted in transit and at rest. So when you initially set up Vault, it will be sealed, which means Vault cannot read its own data because it's encrypted. The only way that Vault can read its own data is if it is decrypted by the encryption key. But the decryption key itself is encrypted by a master key, and that master key can only be formed by putting together a selection of key shares, whatever number you specify. So each of your selected Vault nominees will have their own key share. And in order to form the master key, they all have to put it together and form the master key, which can then be used to decrypt the decryption key. And then once you've decrypted the decryption key, Vault can now read its own data that it has stored. So you gather the shared key holders, you begin the sealing process, you form the master key, and then you would unseal the Vault. And at that point, Vault has access to its own secrets, and you can access these secrets via the API should you authenticate effectively. So an example interaction with Vault. So a Vault user would make an initial call to Vault, and they would authenticate with them. Vault would then check the credentials in the auth backend, which in this case is LDAP. That API request would be logged in the audit backend, which in this case is console. If the credentials have checked out, then Vault will create an auth token with a time to live and a use count. So that means that this token can only be used for over a certain period of time, and it can only be used a certain amount of times. The Vault user then has this token, and they can make a request for a secret. So they would say, I would like access to this secret, please. And then Vault would say, this token is correct. Let me check the policy against this, and it will say, does this particular user with this particular token have access to their requested secret? And if that is a yes, then the API, so the API request will have been logged before the policy was checked. And then, so you would then have access to the secret and it would be found. The secret access would be logged, and then the encrypted secret would be passed to the user with a time to live, and the secret would be decrypted locally. And then the user can use that secret as long as it's within the time to live. So Vault also comes with an enterprise edition. So that means you can get 24/7, 365 support from HashiCorp themselves. Vault also directly integrates with Atlas, which we spoke about before when we were talking about Terraform Enterprise. And also you have hardware security module integration, which means you could place all of those split key shares here in your HSM, or you could transit your master key, so your decryption key. So your encryption decryption key, the key that Vault uses to decrypt all of its own secrets, and that also comes with Vault Enterprise. Vault 0.5 has also been audited as well. So you can equip your organization with Vault with the help of Contino. So we provide a training package in Vault so you can see exactly how Vault is working, and then also how to architect Vault into your infrastructure and how you could set it up as well. And also, once you have it all architected and implemented, how can you store and manage those secrets with Vault effectively? And also, how can you secure the applications that you have in your infrastructure with Vault? All of this you would learn with Contino should you take on the training package. So there you have it. So we've gone through value, efficiency, and security. So you have security with Vault, all of the efficiency that you can gain with Packer and Terraform building into the cloud, and you now understand the value of moving your organization into the cloud with the swiftness and the effectiveness and secureness that the HashiCorp tools could add to your tool set. So here are a few useful links. So everything we've gone through today, you can find all of that information in the documentation should you want to look. And if you want to have a look at how Contino can help your organization, then feel free to take a look over here as well. So Contino, software delivery engines. So that might mean that we transform the way you work with enterprise DevOps and continuous delivery. We can take you into the cloud, transform your infrastructure into the cloud, and then transform your application delivery. So if you wanted to adopt containers, we can help you with that. And also, if you want to transform your enterprise architecture with microservices, then we can help you with that too. But we work differently. So not only do we deliver on the key strategic technology initiatives, but we help to upskill your workforce and support the development throughout the whole process. And because we work with such a large amount of clients, it means that we've developed significant IP around all of these, around adopting all of this transformation and adopting all of these associated technology stacks as well. So here are a few of the cloud. But that's it. Thanks, guys. So I've been Jordan Taylor. So if you wanted to ping me an email at all, here's my email address. If you want to contact me on Twitter, it's just here. I've run over time a little bit, and I do apologize. So if you do need help, so us guys at Contino, we can help you with that. And if it's not so difficult to get the value, efficiency, and security that I've shown you today, so feel free to get in contact. So has anybody got any questions? Can I hand over to you, Augustus? Is that what you'd like me to do?
Hi, Jordan. If we can go straight on to questions and answer session, if there are any questions.
Yeah, sure.
Thank you.
Okay, so yeah, I've got one question here. So why would you use Terraform Enterprise, and why not just run it all from Jenkins? So you could run it all from Jenkins, and it would be just as effective if the correct workflow was around it. But you don't have the auditing capability that Atlas offers. Should you want to roll back state or anything like that, it's all down to Jenkins, and all Jenkins is doing is running those Terraform commands all from one place. Whereas Terraform Enterprise, it makes it so you don't have to have all of that confidence in your operators, because it's all being ran and there's access controls around all of the actions that happen with Terraform because you're using Atlas. So that is why you should probably adopt Enterprise over just using Jenkins. But you can just use Jenkins if you wanted to. So specifically for AWS, so we've got another question here from James. So specifically for AWS, how much does Terraform lag behind new AWS features and CloudFormation? So I don't know so much about CloudFormation, but there are that many. So the way HashiCorp works is all of the tools that they have are very much community driven. So which means that whenever you need functionality for a particular tool, you can go ahead and contribute that. You can go ahead to GitHub and you can make that pull request and you can get that. Does anybody else have any questions? So an example architecture would be all of your VPCs. So you have your 5 VPCs. So a management VPC where we would template a Jenkins node, maybe a Chef server, a GitHub Enterprise server, should you want to, and then so all of the networking that comes with that. So the security groups around each of those management nodes, so that they can all talk to the correct nodes that they need to, and then outside of your management VPC, you could then have your dev, test, your prod, and your pre-prod, all of which have all of the templated networking configuration and also any of the nodes that need to be built into. So with that, then you can then have all of your different subnets and all of your different web servers, your databases in each of these environments, all pre-configured as code. And then with the VPC peering into the management VPC, you can then do all your provisioning from the Chef server, which sits in your management VPC, and then all of this templated infrastructure is as code, and that is it's just a full environment, a full platform ready to go. Okay. So I'm just reading through the questions. So I got a question from Christoph. So he says, a lot about managing infrastructure is also about managing / handling changes to it. How does a typical workflow would look like when you use Terraform, etc., especially around testing of new features and changes? There seems to be some pattern emerging, but everyone does things by themselves at the moment. I'm curious how Contino does it. So it very much depends on what is it you're wanting to test. So if you're just wanting to add a new if you just wanted to add a new node into your infrastructure, then you would template that into your dev environment, which is with your so the dev directory of your Terraform repository. You just pull in a new node into there, and then once you build that particular environment, that would be you testing. That would be you proving out that this resource fits into your infrastructure without any issues, and it's not affected anything. And if that's successful, that is when you can progress it into the new environments. So Fritz has said, is there investment required? No, there is no investment required whatsoever. So Terraform is open source. You can go ahead, you can pick up Terraform today, you can start playing with it, as long as you have a cloud provider account, and you can just take a look at the Terraform documentation and you can build whatever you require into the cloud. And you could take that back to your organizational team and say, look, we can take on this tool. But I think the important thing, so you can easily adopt the tool, but it's important to get help with the workflow. So you need to make sure that when you're taking on these tools, you're deploying infrastructure, you're deploying what runs your business. You need to make sure that that is all in place correctly. So how much would you, so Darren has said, how much would you bake into Packer as opposed to Terraform building? So ideally, you would bake everything into Packer. So Packer is the end game. So take Netflix, for example. So they bake all of their configuration into all of their images, and their full infrastructure can be built within seconds because everything is pre-baked in Packer. But in order to get to that stage, it means that you've got to have your configuration management perfected, and it all runs from Packer, and then you would have a consistent CI/CD workflow. So every time a new, I don't know, Chef Cookbook or Puppet module comes through the system, you would then want to be recreating Packer images to then be picked up by Terraform the next time it gets built, or have your blue-green deployments take that node down and replace it with the newly provisioned Packer image. But overall, that you want to be aiming to get everything pre-baked, so you can have, so should you take on auto-scaling, for example, so by auto-scaling I mean when traffic hits a certain level and you need to expand the resources that you have, then you need to have that resource ready to go. You need to have that image ready. And the only way you can do that is if it's pre-baked and it's all pre-configured. And that is why you should aim to get your full infrastructure ready to go. So it needs to be deployable within seconds. So my advice is try and aim to get everything in Packer eventually. Would I recommend paying for Atlas? So Christoph has asked, would you recommend paying for Atlas and the integration it offers, or rather build something yourself, especially around handling the remote state management? So I think that if you're working in big teams with and where this infrastructure is critical, everything is in the cloud, then I definitely think you should have Atlas, because it provides that extra confidence that nothing is going to go wrong. There's also all the auditing capability that you should require, and you have the support from HashiCorp throughout that whole process. Whereas if you're just doing it yourself, if you're just using all from Jenkins, for example, yes, you're building it all from one place. Yes, you can have that remote state. You can have it all ran from one place, but where's your safety? Like it's just that extra level of confidence should you use Atlas, because it is designed to tackle this challenge. So yeah, I would advise that, yeah. So Christoph's asked, how does Terraform handle changes from outside of the state? So for instance, when you programmatically change the size of an ASG or swap instances attached behind an ELB externally to Terraform. So I don't fully understand your question. So swap instances behind an elastic load balancer externally to Terraform. Do you mean that you don't want to swap those instances with Terraform? Is that what you mean? Sorry. If you could just message me back on that one, and I'll move on to the next question. So, Darren, so I'll answer your question now. So Darren has asked, Atlas is cloud-based, i.e. no on-premise version. Is that right? So at the minute, it is cloud-based, but I'm not 100% on that is the answer, because I used to previously work somewhere where it was being taken into consideration and it could have been a possibility, but you can't. But I don't know about that is the answer. You're best off getting in contact with HashiCorp, because I'm pretty sure if it was the right use case and it could be a consideration is the answer. I don't know. Does anybody else have any questions? No, I've got a few there. Yeah, for example, blue-green. So when you want to, so Christoph has just replied to his previous question, which was, how does Terraform handle changes from outside of the state? For instance, when you programmatically change size of an ASG or swap instances attached behind an elastic load balancer externally to Terraform. So he then extended that question to say, for example, for blue-green, when you want to replace instances behind an ELB, would you manage this with Terraform or a custom solution outside of it? So this definitely fits in with the use case of Terraform. So Terraform has a command called Terraform taint, which means when you say Terraform taint on a particular resource, that means that resource is going to be recreated next time there is a Terraform apply. And with that, that means that, so if you have numerous web servers sat behind an elastic load balancer, you taint one of them, next time you Terraform apply, that single node will be taken down and then it will be brought back up and re-provisioned. So if you change the cookbook for that node when it's provisioned, then once it gets brought up, it will have the new configuration. You could then template the next one, do the same, template the next one, do the same. But with that, you would get your zero downtime from that, and that is how you would do blue-green deployments around that. You would probably want to do that from a build platform such as Jenkins, or you could do it from the command line if you wanted to. But yeah, that is definitely fits in with the use case of Terraform. Okay, so we got a question from Rawlings Sam. So Rawlings, I'll assume your name's Rawlings and not Sam. So how does configuration management tool like Chef or Puppet install packages on Packer images? So Packer has a series of plugins for each of these provisioners. So I know that there's a Chef one, there is a Puppet one, there's a Puppet masterless one. So these are all, so with Packer already offer the plugins to actually use each of these configuration management tools. But should you not have one, then it's just the same as running a command. So you can make Packer run remote executed commands. So you could go ahead and you could install Ansible. You could go ahead and then you could place all of your Ansible playbooks onto that node. You could then have a command that actually runs those Ansible playbooks. But there is so you don't need the plugins to do it with Packer. But Packer does offer a lot of plugins already, and I recommend checking out the documentation. So if you go Packer.io docs, you can see all of the provisioners that are available already, and there's a lot of documentation on how you can just pick up and use those straight away. Okay, so David has asked, David Aiken has asked, how does HashiCorp fit into the Docker Datacenter? So the honest answer is I'm not 100% sure, but I know that. So when you're taking on a tool such as Nomad, you can use that to schedule all of your containers across your infrastructure with that. So that's where that fits in with Docker. With Vault as well. So Vault can be running on Docker. The Vault cluster can be running on Docker, and you can also make it so you have Nomad, which is controlling of all of your Docker stuff, and you can make it so Docker and Vault are tightly integrated. So every new Docker container that Nomad is interacting directly with Docker, with Vault, sorry, and it's placing those secrets as required where they need to be. And because of how Vault works, so if you have a Docker container that becomes unhealthy, you can make so it can't renew a secret from Vault, and Nomad is informing Vault that particular node it should be revoked, basically. So that secret is revoked, and these are just two examples of the tools that fit straight into Docker. So then we have another question from Christoph. So also, does HashiCorp offer sensible SLAs? And what if Atlas goes down and you need to change something? So I don't know the answers to those questions, unfortunately. But if Atlas is definitely something you're interested in, and it's something that you want information on, then the guys at HashiCorp are very helpful when it comes to giving you like some insight or strategy around how you should take on some of these tools. So I definitely recommend getting in contact with those guys. Are there any more questions?
That's all the questions, Jordan. Lots of questions there.
Yeah, cool. Thanks, guys.
Yeah. We would like to thank Jordan for his brilliant and insightful presentation. Thanks everyone for joining today's webinar. We hope you found your participation of use. We'll make the recording available afterwards and send you the link. If you have any further questions, please email us at info@unicom.co.uk and we'll forward these on to Jordan, who will respond directly. We look forward to your future participation at another Unicom event. Thanks everyone.
Thanks guys.